pick up in 10 seconds at the T-minus 9-minute point. Approximately 5 seconds. 3, 2, 1, T-minus 9 minutes and counting. The launch events are now being controlled by the ground launch sequencer from now up to T-minus 25 seconds when they switch to the onboard redundant set launch sequencer. The ground launch sequencer is part of the processing system and operates by relaying commands to the orbiter's onboard computers, which then report back to the launch processing system when the commands have been executed. The primary job of the computers is to check that all of the launch commit criteria, such as propellant loads, temperatures, pressures, and other measurements, are proper. The launch and recovery director has ordered the chase planes to take off. Coming up on the 8-minute point in the countdown, T-minus 8 minutes and counting. Everything proceeding smoothly towards an on-time liftoff at 1:30. The liquid oxygen fill and drain valve in the external tank has been closed and topping of the tank completed. Liquid oxygen drain back has been started. This means that liquid oxygen is flowing through the main propulsion system and back to the large storage tank to cool the system down slowly to 270 degrees below zero, so they'll not be shocked by the torrent of super cold fluid. T-minus 7 minutes, 27 seconds, and counting. At the T-minus 7-minute point, the crew access arm will retract and is in the process of retracting right now. This is the walkway used by the astronauts to get from the service structure to the orbiter. If an emergency should arise, that tower can be put back in position within 15 seconds. T-minus 7 minutes and counting. Like other things in the countdown today, we have been just slightly ahead of schedule as we go down towards a liftoff. T-minus 6 minutes, 30 seconds and counting. At the 6-minute point, the crew will perform the auxiliary power unit pre-start, which consists of positioning a number of switches and verifying that they are in the proper position, then throwing the 3 propellant isolation valve switches which allow the hydrazine fuel to start flowing from the tanks toward the APUs. Coming up on the 6-minute point, T-minus 6 minutes and counting. The pilot, Carol Bobko, has been asked to perform the APU pre-start. T-minus 5 minutes, 49 seconds and counting. T-minus 5 minutes, 40 seconds and counting. The flight recorders are on. The flight recorders provide measurements of the shuttle system performance during the entire mission for playback after landing. T-minus 5 minutes, 25 seconds and counting. Everything going smoothly towards our liftoff. And we have a go for APU start coming up on the 5-minute point. T-minus 5 minutes and counting. I have go for APU start. APU start is in work. The APUs, or auxiliary power units, provide hydraulic power to move the aerosurfaces and main engines for steering. The astronauts have closed their visors. T-minus 4 minutes, 30 seconds and counting. The firing circuit for the solid rocket boosters ignition and range safety destruct devices has been armed by a ground launch sequencer command. This is accomplished by a motor-driven switch called an arm and safe device. The system is then inhibited to prevent premature ignition. T minus 4 minutes, 5 seconds and counting. The main fuel valve heaters have been turned off in preparation for engine start. The main engines on the orbiter will actually be started at the T minus 6.8 second point. It takes 3 seconds for them to reach 90% thrust, at which time the solid motor ignition sequence starts. T minus 3 minutes, 40 seconds and counting. The elevon, speed brake, and rudders are now being moved through a pre-programmed pattern to ensure that they're capable of doing their jobs during flight. T minus 3 minutes, 27 seconds and counting. The shuttle is now on internal power. However, the fuel cells are still receiving some fuels from ground support equipment for another minute. T minus 3 minutes, 13 seconds and counting. The profile checks of the aero surfaces is complete and verified, and the aero surfaces are in launch position. Coming up on the 3-minute point, T minus 3 minutes and counting. The engine gimbal or movement check of the main engines is underway. The liquid oxygen valve for filling the external tank is closed and pressurization has begun. T minus 2 minutes, 45 seconds. The gaseous oxygen vent arm is being retracted. T minus 2 minutes, 30 seconds and counting. The fuel cell's ground supply of oxygen and hydrogen has been terminated and the vehicle now on its onboard supply. The beanie cap or gaseous oxygen vent arm carries away vapors from the oxygen tank while the tank is full on the pad. Coming up on the 2-minute point in our countdown, the main engines have been moved to their start position and the astronauts have cleared the caution and warning memories. T minus 1 minute, 56 seconds, and the liquid hydrogen vent valve has been closed. Flight pressurization is underway. T minus 1 minute, 45 seconds. At this point, the computer automatically verifies the readiness of the main engine. T minus 1 minute, 30 seconds and counting. The liquid hydrogen tank is now reaching flight pressure in approximately 5 seconds from now. T minus 1 minute, 20 seconds and counting. The liquid hydrogen tank is at flight pressure. Coming up on the 1-minute point in our countdown. T minus 1 minute and counting. The firing system for the sound suppression water system is armed. T minus 55 seconds, and the hydrogen igniters under the orbiter's engines have been armed. These devices are used to ensure any hydrogen flowing through the engines prior to engine ignition does not accumulate. T minus 40 seconds and counting. We are just seconds away from switching command of the countdown to the onboard computers. T minus 30 seconds and counting. We are go for auto sequence start. The hydraulic power units on the SRBs have started. T minus 20 seconds and counting. T minus 15, 14, 13, 12, 11, 10. We're go for main engine ignition. 7, 6. We have main engine ignition. 4, 3, 2, 1, 0, and liftoff. Liftoff of the Orbiter Challenger and the 6th flight of the Space Shuttle. The shuttle has cleared the tower.
Challenger's underway with our program. Houston copies, Challenger. The period of maximum aerodynamic pressure. "30 seconds elapsed. Throttles on all three main engines coming down to 81%. Velocity 2,000 feet per second. Altitude 3.5 miles. Downrange 2 miles. 1 minute elapsed. Main engine throttle is going back to 104%. Challenger is go at throttle up.
Challenger, you're go at throttle up.
Roger, go at throttle. Trajectory slightly depressed, no problem. Flight dynamics officer reports.
Challenger, Houston, we see you're slightly depressed, no problem.
Okay, Dick. Velocity 4,100 feet per second. Altitude 15 miles. Downrange 14 miles. Velocity 5,100 feet per second. 20 miles in altitude. Downrange 22 nautical miles. Standing by for solid rocket booster separation. SRB-7 was that something. We got an awful lot of crud on the windows at SRB-7, Dick.
Roger, we copy that. Challenger, your first day's performance was nominal.
Okay, thank you. Guidance has converged. Velocity now 6,000 feet per second. Altitude 31 miles. Challenger is 46 miles downrange.
Challenger, you have 2-engine tail capability.
2-engine tail. Challenger now capable of a transatlantic abort to Dakar Airport on Africa's west coast if one main engine fails. Three minutes elapsed time. Velocity 6,800 feet per second. Altitude 39 miles. Challenger 70 miles downrange. All three main engines still at 104%. Challengers go at 3 minutes 15 seconds. Flight Director Jay Green taking a status check at all positions prior to Challenger reaching negative return point. Velocity 7,800 feet per second. 47 miles altitude.
Challenger, your negative return.
That's negative return.